Chapter 5, Part 2, here we go. Today we are going to be asked to solve inequalities and then graph the solution set just like yesterday, but today we are going to see these absolute values. When we see these absolute values, we have to do a couple different things. Now, the very first thing that we do with absolute values, we have to take out whatever's inside the absolute values if the absolute values are by themselves. So the absolute values by themselves, so we take out the x minus 4 and then bring down our less than 9. So that's one thing that we have to do. Then the other thing we have to do, right? Remember, this is an absolute value. Whatever comes out of the absolute value has to be positive, right? Well, this would be the positive answer, and also it can be negative, right? So a negative 4 would turn into a positive 4 in the absolute value, so we have to take that into account. So we take that into account by going x minus 4, still whatever's inside the absolute value, but we have to change now the inequality and make the number negative. So we took out whatever was inside the absolute value, we changed the inequality, and we made the number negative because in this case it was positive. So now once you do that, you did the hard part. Now it's just solving these inequalities just like you did yesterday. So we add 4 to both sides to get x is less than 13. Here, let's solve the other one. We add 4 to both sides to get x is now greater than negative 5. So let's go ahead and graph this. We have negative 5 down here. We have 13 way over here. And then let's put 0 right smack dab in the middle. Now, x is less than 13. It's going to be an open circle. We are going to be shading to the left because my variable is on the left. The arrow points to the left. Next, we're going to be shading x is greater than negative 5, so open circle. On negative 5, we're going to be shading to the right because the arrow points to the right. So since both arrows are pointing in, we are going to shade everything that is inside our 2 points. Let's look at number 2. Again, we have two absolute values. So when you see the absolute values, we have to do two things immediately. First thing we have to do, take whatever's inside the absolute value and take them out and rewrite them just with an inequality just like what we did yesterday. And then do the exact same thing with 2c plus 3, but now you switch the inequality. We switched the inequality and made our number negative. If our number was negative, we would make it positive, but since our number is positive, we make it negative. So now again, we just solve the inequality just like we did yesterday. So subtract the 3 from both sides. Then we have 2c greater than or equal to, that is 8, divide by 2, divide by 2, so c now is greater than or equal to 4. Same thing with the blue equation. We subtract 3, subtract the 3, 2c is less than or equal to negative 14, divide by 2, divide by 2, c is less than or equal to negative 7. Again, go ahead and put these points on the number line. I'm putting negative 7 down here, I'm going to put 4 over here, and then I'm just going to put 0 somewhere in the middle. Now, for the red equation, c is greater than or equal to 4, so it's a closed circle on 4. What way are we shading? We are shading to the right because the variable is on the left, so we can follow the arrow. Over here in the blue, the variable is on the left, we can follow the arrow, so closed circle again, shading to the left. Now, since it's shading out, this is going to be an OR statement, so we can fill in both of these lines. And there is our graph for the absolute value of 2c plus 3, which is greater than or equal to 11. Let's try number 3. Now we have a fraction in the bottom, but that does not concern us. That doesn't change anything because we still take 2t plus 6 all over 2 out of the absolute value, make it greater than 10. Also, we need to take 2t plus 6 out of the absolute value all over 2. And now remember, we switch the sign and make it negative. So we changed two things. We switched the signs and we made it negative. Now we just go ahead and solve for the inequality just like what you would do before. So we multiply both sides by 2. Multiply both sides by 2. So we get 2t plus 6 is greater than 20. We're solving for t right now, so we subtract 6 from both sides. Then we have 2t is greater than 14. We divide by 2. So divide by 2, divide by 2. T is greater than 7. Same thing with the blue guy. Multiply by 2. Multiply by 2. So we have 2t plus 6 is less than negative 20. We subtract the 6. Subtract the 6. So we have 2t is less than negative 26. Then we have to divide by 2. Divide by 2. So now t is less than negative 13. Again, we go back to our number line. Negative 13 down here. 7 all the way over here. 0 in the middle. Starting with our red equation. It is an open circle on 7. The variable is on the left. We can follow the arrow. So we are going to shade to the right. Blue equation. The variable is on the left. We can follow the arrow. It is an open circle. On 13 we are shading to the left. And so now since we're shading away from each other, it again is a OR statement. It is a OR statement. Now 4. Now we are asked to graph these inequalities on a coordinate plane. So we graph these things exactly the same way as we would an equation. So how do we do that? Well, from this guy, it is already in slope-intercept form. So our slope is whatever is in front of the x value. What is in front of the x? A 1 is in front of the x. What is our y-intercept? Our b is negative 3. So let's go ahead and graph this line. So let's go down 1, 2, 3, put a point. Then we go, our slope, we go from that point we just drew. We go up 1 and over to the right 1 because we want a positive slope. So we go up 1, over to the right 1, up 1, over to the right 1. So we have enough points now that we can draw a line. Now, here is the tricky part. We are drawing a dotted line for a reason. I did not pick that dotted line by accident. Why is it a dotted line? It is a dotted line because we have a greater than inequality. A greater than or a less than inequality means dotted line. Another thing that we have is that we have to shade on one side or the other because there's coordinate points that make this guy true. And how do we do that? I'm always going to pick, for right now, coordinate point 0, 0. Remember, this is an x and a y. So I'm going to put 0, 0 in for x and y. So my equation was 0 is greater than x minus 3. So I'm putting 0 in for y, greater than 0 minus 3. So is 0 greater than negative 3? Is 0 greater than negative 3? Ask yourself that question. Yes, it is true. We want to shade the line where it is true. So yes, 0 is greater than negative 3. So we are going to shade where our equation was true. So we are going to shade above the line because we picked this point, 0, 0. We plugged it in. Since it was true, we're going to shade where it was true. If it was false, we wouldn't shade over here. We would shade on the other side. So let's try one more example. Number 5. Now we want to put this in y equals mx plus b, slope-intercept form. So the very first thing that I want to do is subtract 3x to the other side because we want to get that y all by itself. Then we still have this negative. So remember, when we change signs, when we multiply or divide by a negative, we have to flip the inequality. So I'm flipping the inequality. Then I have 3x minus 4. Now we have a slope of 3. We have a b or a y-intercept of negative 4. So let's try and graph this. We go down 1, 2, 3, 4. Put a point. And what is my slope? It is 3. So from this point that I just drew, I go up 1, 2, 3, and over 1 to make a positive slope. Again, I go up 1, 2, 3 over 1 to make a positive slope. Now, once you have 3 dots, you can go ahead and draw a line. And now again, I am drawing a solid line on purpose. Why am I drawing a solid line? Because our equation tells us to. Our equation, or sorry, not our equation, our inequality is an equal to sign. So when it looks like this, we have a solid line, if you can read my handwriting. Now, since we have a solid line, we have to do one more thing. We are going to pick point 0, 0 and plug it in to see what side we shade on. So I'm plugging 0, 0 in for y is greater than or equal to 3x minus 4. So I have 0 is greater than or equal to 3 times 0 minus 4. So I have 0 is greater than or equal to 0 minus 4. 0 is greater than or equal to negative 4. So is 0 greater than or equal to negative 4? Yes, it is. Since this is true, the only reason I am shading this side is because I answered yes, is because it's true. So I shade where it's true. Now, you do not have to use 0, 0. You can use any point that you want to. But if the point is false, you have to shade on the other side of the line. So if I would have picked point, let's go with 4, negative 5. If I would have picked this point down here, it would have came up false. If it would have come up false, I would have to shade on the other side. All right? And I lied, we have one more slide to cover. Now we are asked to determine the ordered pairs that are part of the solution for each inequality. So all we're doing here is taking these ordered pairs and plugging them in. Remember, these ordered pairs are an x and a y. So how we do this, we put 1, 1. So this one is going in for y because it's the y. That is going in for the x. So we have 1 plus 1 is greater than negative 3. Well, 1 plus 1 is 2. Is that greater than negative 3? Yes. So that is part of the solution. How about the next one? 0, 0. We put 0 plus 0. Is that greater than negative 3? 0 is greater than negative 3, so that is a solution. Now, how about, and I'm going to change this up a little bit, how about negative 2 and negative 2? So negative 2 plus negative 2, is that greater than negative 3? Well, negative 2 plus negative 2 is negative 4, and is that greater than negative 3? Is negative 4 greater than negative 3? No, so this is not a part. And then finally, we have 1, 2, so let's go 1 plus 2. Is that greater than 3? We have 3 is greater than 3, so is that a part? So is 3 greater than 3? No, 3 is not greater than 3. 3 is greater than or equal to 3, but for our case, 3 is not greater than 3, so it is not part of the solution. And now that does it for Chapter 5, Part 2.